So this is the beginning of fourth quarter. It says semester 2, second 9 weeks, sheet A. So really fourth 9 weeks for us. The first type of problem, the name is simplifying rational expressions. So simplifying rational expressions. So I think I should probably explain what rational expressions are. Rational expressions are any kind of fractional problem that has variables in it. So basically what's going on here with problem A, it is a quadratic equation over a quadratic equation. That makes it a rational expression. Okay, because in the past when we talked about monomials and such, you could not have variables in the denominator, and this is something completely different than that. This is called a rational expression. You have some kind of algebraic expression on the top, and you have an algebraic expression on the bottom, so both numerator and denominator. Here is what we do with these. You have to factor, so we're using what we learned in third 9 weeks, factor top and bottom. Cancel common factors, just like you would do in a regular fraction. Cancel common factors. And rewrite. So again, simplifying rational expressions is what this is called. You factor the top and the bottom, and you cancel common factors and rewrite. So you see that this type of problem, we are using the things that we learned in the third 9 weeks. So hopefully you remember this. If not, we'll talk about it here again. We're looking at x squared minus 6x minus 16. So you look for a common factor in all of those terms, and there are none. So your next logical step then is to put 2 sets of parentheses down for this. You look at your squared term. What gives you x squared? X and x. So you go ahead and fill x and x in. All right. Next place that we look is the sign in front of the constant term, and it is a minus. What does that tell us about the signs? Different signs. So just go ahead and put arbitrarily a plus and a minus. It doesn't really matter what order. That's just usually what I do. You don't have to. Okay, the next thing that we do is we now look at the 16, and we want to come up with the factor pairs that give us 16. So I would start 1 and 16, 2 and 8, and 4 and 4. Okay, so we've got those 3 choices. Since it is a minus in front of the 16, you have to say which of those factor pairs has a difference of 6. So which set am I going to use? 2 and 8, perfect. Okay, this is where this sign in front of the 6 comes in. It's a minus. So I got to use 2 and 8, but I got to use them in the right spot now. So what does that tell me if there's a minus in front of that 6? I need it to be negative when we put them together. So which number goes where? Where does the 2 go? Where does the 8 go? 8 goes with their minus, and 2 goes with the plus. Okay, so we have factored that top trinomial, and we're ready to do the bottom. So x squared minus 5x minus 24, look for a common factor. There is none. Now we're going to put our 2 sets of parentheses. You look at the x squared, and what am I going to write in my parentheses? X and x. I look at the sign in front of the 24, and since it's a minus, what does that mean? Signs are going to be the same, plus and minus. I look at the 24, and I'm going to now list my factor pairs. There's a lot of them. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Since it is a minus, I want the factor pair whose difference is what? What am I looking for? The factor pair has a difference of 5. And there's a minus in front of that 5. So let's see, which factor pair has a difference of 5? Yep. And since it's a minus in front of the 5, where do my numbers go? Yeah, plus 3 minus 8. Okay, so we have factored the top and bottom. If you're really good at that factoring, those problems aren't going to take you very long. Because I think now you can see it says cancel common factors. Common factors are not just pulling out an X out of that. When you have a set in a set of parentheses, it is a set. That X plus 2 is a set of X plus 2. It can't be separated. You can't take a 2 out of that and cancel it out with an 8 somewhere else. That set, X plus 2, is attached. And it's only canceled with another exact X plus 2. Same way with X plus 3. There's nothing there that says X plus 3 but that one set. But look at my X minus 8s. I got 2 of those, right? One on top and one on bottom. So those are the common factors you cancel out. When they look exactly the same in the parentheses, those can be canceled. Nothing else cancels, so here is my answer. This is why it says to rewrite. You can't leave it looking like that. You say X plus 2 and X plus 3. All right, questions on that? Let's look at B. All of these sheets that we're going to be working on, they have one topic and then 2 problems because there's 10 new topics. All right, sheet B, or example B, I should say, 1B. X squared minus 25. What's that called? It's a binomial, but it's a special one because the x is squared and then 25 is a perfect square. What? Well, they're quadratic equations. Very good. Anything that has a squared term makes it a quadratic equation, yes. But it has a minus in the middle, so that would make me think about the word difference. And it's the difference of squares. It's called a difference of squares. So when you have a minus in the middle, and then a perfect square here, and a perfect square here, we do these 2 sets of parentheses, difference of squares, and you write the square root of x squared plus the square root of 25, x plus 5. What goes in the other set of parentheses? Yes, x minus 5. Because remember, when you multiply those back together, if you need to, the outer inner are opposites and they fall out, and that's why there's only 2 terms. So x plus 5, x minus 5. Okay, let's look at the bottom trinomial. No greatest common factor. If there would be, you need to take that out of there, but there isn't. 2 sets of parentheses. So for the x squared, what am I going to put? X and x. This time there's a plus sign in front of the 10. What's that mean? The signs are the same. Well, how do I know which signs to put in there? Yeah, you look at the sign in front of the middle term and it's a plus, so that means they're both plus. You look at the factor pairs of 10. So 1 and 10 and 2 and 5. This time, since it is a plus in front of the 10, you say the factor pair that adds up to 7. So which set is that going to be?
2 and 5.
Yep, and since the signs are the same, it doesn't matter which way you put them. So x plus 2, x plus 5. Now, do I have any common factors that can cancel, do you think?
Yes.
What would that be? The x plus 5s cancel. So again, you can only cancel the sets, not individual parts of them. And I finish off by doing x minus 5 over x plus 2. All right, questions about that guy? Okay, let me see. Everybody done writing or not? Yes. All right, we're moving down to number 2. All right, number 2 says that it is multiplying rational expressions. So multiplying rational expressions. Now, I hope you realize these rational expressions are a lot simpler than the ones we just had up in problem 1. These are just monomials that they've got thrown in there. Here's what we're going to do. You cancel common factors. Cancel common factors from top to bottom. And multiply and rewrite. Okay, so when we say common factors from top to bottom, you see there's no plus or minus signs in between? So pretty much everything in that problem is kind of on its own. It can be canceled out with anything else that's there. You don't have to worry about it being with a set like we did up at the top. So what I would do is just start, for the problems, is start from left to right and start canceling anything from top to anything from the bottom. It could be right above it, it could be diagonal from it. So 15 is where I'm starting. If I have a 15 on top, is there any common factor on the bottom anywhere that I could cancel out with? The 3. So I'm going to go ahead and cancel the 15 and cancel the 3. The 15 I'm going to replace with a 5, and the 3 is going to be a 1. Do you see how this could become really messy and you have to write really neat? Hopefully you'll see that in a minute because this is going to be hard to keep straight here. All right, x cubed. Do you see anything on the bottom that I could cancel out with x cubed? X squared. So what that means is since there's 3 on the top and 2 on the bottom, all of them are gone on the bottom, right? And the 3 becomes a 1. Okay, I go to my y. Does y have anything to cancel out with? Yeah, there's 4 on the bottom in there. So I'm going to cancel the 1 on the top out completely, and the y to the 4th becomes a 3. Okay, I'm going to my 14. 14 got anything to cancel with?
7.
The 7. So I'm going to cancel, mark those out. 14 becomes a 2, and 7 becomes a 1. I've got a to the 6th. So what's that cancel with? A to the 4th. So the 4 on the bottom are gone completely. My a to the 6th becomes a 2nd. And then the b on top by itself cancels completely, and the b2 on the bottom becomes a 1. Now, the hard part is seeing what you really do have left. So on the top, I have a 5 times a 2. The 14 became a 2, right? 5 times 2 is 10. The x is on top, and a to the 2nd on top. On the bottom, I have only 1s, and I'm not going to write those for the numbers unless there would be nothing else. And then I've got a b and a y to the 3rd. Okay, here's what I'm going to make you do. I need for you to write those letters in alphabetical order when you're done. Okay? So that means it's going to be 10a squared x over by to the 3rd. If you have the foresight to see that as you're multiplying, you can do it kind of in one step. I didn't want to do that just this first time. Okay, questions about that?